Okay, everybody, I have two more kinds of problems that you might find in 11-3. So let's go ahead and try to look at those as well. Example 5 tells us that 36 minus t squared over 5t minus 30 is our problem, and we want to simplify this and also state whatever excluded values we might have. Remember, excluded values, all it means is the denominator is 0 when we have to find that entire denominator that's 0. So let's take a look at that numerator. What can we do with that? First of all, that looks kind of weird. Don't we usually have the variable first? Truth is, it doesn't matter. We can write this as, we know that this is a difference of two squares, so we can know right away that this is going to be a 6 plus t and a 6 minus t, right? Check me out. FOIL that and see if you get this. Okay. Honestly, check me out and make sure that you can get it, because you got to get fast at that unless you want to spend the rest of your life doing algebra homework, which you don't. But you have to practice enough so that you can do it quickly. Okay, let's look at the bottom. Let's see, how are we going to do that? How can we factor that? We don't have any squared things. We only have two terms. What's common between those two terms? Anything? I sure hope you said a 5. I've got a 5 in both of those. If I factor the 5 out of here, I'm left with t. And if I factor the 5 out of that negative 30, I'm left with a negative 6. Well, gee, I don't think I like this, because I have got nothing the same. This group doesn't have a matching group on the bottom. This group has a positive 6 and a negative 6 is on the bottom, with a negative t here and a positive t here. So, you know, I don't have any common groups that I can cross off in the top and bottom. So what was the point of doing all this factoring, right? Well, in this case, there is something common on top and bottom that you can cancel. But the point is that you've really got to look and be clever about how you're viewing everything. In this second term, does it just strike you that there's something that's very similar about these? There's a 6 minus t here, and here's a negative 6 plus t. I could write it the other way, right? I could write it as 6 plus t times 6 minus t. It doesn't matter what order I add, so I could actually write this as a negative 6 plus t. And I haven't changed anything, right? Well, what would happen if I also factored out a negative 1 right here? If I took a negative 1, divided this negative 6 by a negative 1, what would I get? If I divided that negative 6 by a negative 1, I'd get a positive 6, right? I'm going to factor out that negative 1 right there. And if I factor out a negative 1 from this positive t, I'm going to get a negative t, right? So I could actually factor out a negative from here, and I'm going to change the signs of these, and that's going to give me, nothing has changed on the top. But look, now it matches what we have there. And now I can factor this off, or I can cancel that, and I'm left with a negative 6 plus t over 5. Or you could also say negative 6 minus t over 5. And that's just distributing that negative sign all the way through. Okay. And what are the excluded values? Well, I can see from right here, if t is 6, what's going to happen in the denominator? It's going to be, the whole thing will be 0. So I say my excluded value is t equals 6. And this is my entire answer. Now, this is a little bit tricky to look for this, but you should see right here that we have a negative t and a positive t, and a negative 6 with a positive 6. So if I were to change the sign of one of these all the way through, I would be able to get the other one. This time I chose to change the bottom one just to match the top, but when you get to be really, really good at doing these problems, you'll be able to see it so quickly you won't even have to do all this extra work that I did to rewrite it out. Let's try another example. 5A on the bottom of 686. 5A. here we go with 12x plus 36 all over x squared minus x minus 12. We know we're going to factor everything we possibly can. If we factor everything we can, what are we going to do at the top? What's common to both of these things in the numerator? 12. 12, when I factor out a 12 out of the 12x, I will have an x left over. When I factor a 12 out of 36, I have 3. Make sure that when I distribute that through, I'm going to get back to this thing. Okay, there we go. How about factoring the bottom? If you're getting good at factoring, you should be able to factor this without even thinking about it. It's going to be an x minus 4 and an x plus 3. If you need to take another second to prove that to yourself, please pause the video and make sure that you do. Now I've got an x plus 3 on the top and an x plus 3 on the bottom. Those whole groups cancel off, and I have 12 over x minus 4. Okay, 12 over x minus 4. What have we not done? We have not found the excluded values, but we can look here and we can see that an excluded value is going to be when x equals 4 or negative 3. And that is the answer to this problem. Okay. Let's also do 5b. X squared minus 2x minus 35 divided by x squared minus 9x plus 14. Go ahead and pause it and try to do all of this on your own. When you come back and restart, you should be able to see that the top is going to factor to an x minus 7 times x plus 5. And the bottom is going to factor, see, we've got to multiply to 14, add to 9. 14 would be 2 times 7, right? So x minus 7 and x minus 2. These factor off, and we get an x plus 5 over x minus 2. These were supposed to be practicing that other skill that we just did, but it didn't happen this time, did it? We have excluded values where? Excluded values at x equals 7 or 2. Da-da-da-da. We are done. No problem, not hard. You need to pause the video to go back and look at some example problems that we've already done. No worries. Do that. If you have questions in class, don't feel bad about bringing them up. We need to talk about them. But this is, I think it's kind of fun. We're using all these things that we've learned in algebra all year long to really make our problems a lot simpler so we don't actually have to do very much work, and I think that's pretty cool. Okay, here's another problem. This one we're supposed to find all the zeros that we can. So first we're going to know our excluded value. We've got an excluded value at x equals 3. Excluded value, we can't have an answer there. Let's factor out the top and see what we get. We need to multiply to negative 18 and add to a positive 3. So that's going to be an x minus 6 times an x plus 3, right? I sure hope you're saying no, because this has to be a positive, which means this has to be a positive 6 and a negative 3. All over x minus 3. Okay. If you didn't factor it as quickly as I did, do what it takes for you to understand what it is, what those numbers need to be. You do what it takes because you know what you need to do. X minus 3 top and bottom cancels, and we have an x plus 6. We're left with an x plus 6. The only excluded value we have is when x equals 3. Now, if we're supposed to find the zeros, we want to find when this whole thing is equal to 0. And that is equal to 0 only when x is equal to negative 6. Okay. Remember that anytime something says find the zeros of a function, you know, whatever it is that you're looking at, find the zeros, you're going to take that expression, set it equal to 0, and solve for the variable that you have. That's what find the zeros means. Okay. Let's do 6a. 6a says the f of x, we have a function called f. Our function of x is equal to x squared plus 2x minus 15 over x plus 1. We know we have an excluded value at x equals -1. Let's factor the top. We need to multiply to a -15, add to a +2, so that's an x plus 5 and an x minus 3. 5 minus 3 is 2. 5 times -3 is -15, divided by x plus 1. Does anything factor? No. Nothing factored, or nothing cancels after we've done the factoring. Nothing factors. We do have an excluded value at x equals -1, so that means that can't be in our solution. Okay, but that does not cross off this time, and that's okay. If we want this whole thing to be equal to 0, that means that in the numerator, we have to have a 0 here or a 0 here. That's going to happen when x is equal to a -5 or when x is equal to 3. Those are going to be the zeros. That's all we need to worry about. There's no way the denominator can be 0, can make the whole thing 0, no matter what, right? Now you could say, you know, if you really are into this stuff, you could say, well, you could make x so big that it will essentially make the whole thing 0. So if I set x equal to like 4 Google, that would make the denominator so very, very big that it would divide it. We'd be dividing by a really, really big number, which would make it be equal to 0. But still, that's not going to be exactly 0, right? And we want to find it when it's exactly 0. And even if I were to set x equal to 4 Google, I'd have 4 Google plus 5 here and 4 Google minus 3 here. So that's essentially, that's going to be 4 Google times 4 Google, which is going to be like, I don't know, 16 Google. No, even bigger than that, like 16. 4 Google squared is big. So it's like practically infinity. Divided by 4 Google on the bottom. So it's going to be pretty much 4 Google, not divided by that. So that's kind of something weird to think about. That's all right. If I'm not making sense, we'll get there. Don't worry. Let's do the very last example, 6b. 6b says x squared plus 6x plus 8 divided by x squared plus x minus 2 is going to be f of x. Okay. Again, let's factor the top. Is there anything common to all 3 terms? Not today. Let's see how. I hope you paused the video before you attempted to do this, right? Pause the video. X and x, I've got to multiply to 8 and 6. 8 is 4 times 2. How convenient. 4 and 2. Cool. And on the bottom, is there anything common to all 3? No. Nothing common. Can we factor it the way we did the other factoring? X and x, we've got to multiply to a -2 and add to a +1. So how about it's a +2 and a -1? Does that work for our factoring? I believe it does. This group is the same as that group. Those cancel, and we're left with x plus 4 over x minus 1. Our excluded values are x equals -2 and x equals 1. And our 0 is when x is equal to a -4. This is the key thing to remember. Very, very important. Your excluded values are going to be found when the denominator is 0. Your zeros of the function are going to be found when the numerator is 0. Got it? I sure hope so. We'll talk more in class. Do the best you can. See you then. Enjoy your homework.